guys, welcome back to Rocket Gyan, my fellow space tubers. How are you all? I am so much excited for this mission, and I hope you all are too. And yeah, we have another launch today, and this launch is from Rocket Lab launching the Electron Rocket. And Electron Rocket from Rocket Lab is always interesting because we tend to see some beautiful shots of the liftoff, the onboard cameras, and the deployment. But today, uh, this Electron launch is a special one because okay, I'll tell you afterwards. Okay, let me tell you now only because they are testing it from. They are launching the rocket basically from a new launch pad, and they have made this launch pad recently only, which we'll see also, so don't worry about it. And welcome to the stream, all of you. Hi Angel, hi Wildflower, hi Iron Rove, how are you? And hi BK, you bought a hamster yesterday. Oh cool, hope you are taking good care of that, of the hamster. And make sure that he also or he or she, whatever is, watches this launch. Okay, so let's just jump into this. We have this Rocket Lab launch. As you know, this is a small sat launcher. I don't have to say much about this rocket, but this is a small sat launcher, and this currently only has this Electron rocket, which we'll see. Okay, talking about the Electron rocket, we can have a look at it. They have this neutron rocket also in plans, which is kind of a heavy lift launcher, medium to heavy lift launcher, because right now it is in shortage with the recent tensions between Russia and all over the world. Soyuz is not launching, is not gonna launch much. Okay, and because of that there is a sheer shortage of medium lift launch vehicles, and Neutron comes in the medium lift launch vehicle, so we'll have to wait and see if whenever that comes into operation, how the things would look like. So talking about the Electron, it has 23 launches till date, and it is the only reusable small sat launcher, which is great. 3 dedicated launch pads they have actually purchased one more. I don't remember because what I don't remember exactly, but yeah. Then if you see the overview of this rocket, it's a very small rocket, only 80 meter in height. It has 2 stages mainly, plus a kick stage, wet mass of just 13 tons, and it can put payloads to around 300 kilograms to low Earth orbit. And this, it has a kick stage also. I'll talk about the kick stage in a bit. Okay, let's just have a closer look at the rocket itself. Okay, so we have this rocket here. There you go. So this rocket itself is very, I would say that this rocket is kind of my favorite because I haven't seen much small sat launchers which uses liquid fuels in it. Okay, we have the Astra also, but this rocket has been flying for a while now and has an incredible reliability record. So yeah, so this rocket is about 80 meters in height and has mainly 2 stages. So talking about the first stage, this is the first stage. This has these 9 Rutherford engines. These 9 Rutherford engines runs on RP1 and LOX as its fuel, produces around 24 kilonewtons of thrust. That's it, but that is per engine, so 24 kilonewtons of thrust per engine. So just do it like 24 into 9. Then has a specific impulse of 311 seconds, which is great for RP1 LOX config. And then they have this second stage, or the upper stage, whatever you want to say. This is the vacuum optimized Rutherford engine. This is, and this is same almost, but that is vacuum optimized, and it produces around 25.8 kilonewtons of thrust and has ISP of 343 seconds. Then we have the third stage, which is a curie stage or a kick stage, which is not being shown, but that is an option. That's why it is not shown here. If I switch over to that, now we can talk about that upper stage. This is the upper stage, and if you see, uh, this has basically tendency to restart in the orbit. It has multiple restarts. It has its own avionics, power systems and whatnot. So it actually serves as an orbital platform. And if you see this image correctly, this has a very very small engine which you can see in here, and this side has the solar panels in it. So the power generation is done by this, and we don't know much about this Curie engine, but we just know that it produces around 120 newtons of thrust. And talking about the fuel, we don't know about the fuel because they haven't mentioned it anywhere and they have released it. But initially it used monopropellant fuels, and now it is using bipropellant. So it's a simple pressure fed, I would rather say. It's not a engine but a thruster. That's what I have, you can say, seen in this Curie engine, the kick stage. Okay, so yeah, that is about it. And talking about the reusability factor, as I said, this is the only reusable small sat launcher, and they are right now working towards the reusable plan. But this is how the reusability would look like. They would actually try to catch the first stage booster in mid-air. Okay, so this is not what they are doing today, but they that's what is the plan. And we can have a discussion on why they are not using the propulsive landing rather than this. But just enjoy the method, how they will eventually recover the first stage. This is their recovery helicopter. So they did this mid-air recovery demo, in which they did was they took the electron dummy first stage from one helicopter, like to a certain height, and then they dropped that first stage and made it to attain the terminal velocity. And after that,
Two
let me
helicopters
just
in formation departing to drop zone 30 miles east. Approaching target drop location.
this is the second helicopter which will eventually catch this rocket. So yeah.
And all traffic drop test commencing in 30 seconds. Delta releasing in 5, 4, 3, 2, 1. Release.
And soon after the release, it was able to open the parachutes. This was and you can see now this thing, thread kind of a thing, is hanging from the parachute, and this is what actually enables the helicopter to catch it in midair. You see that happening. So this is how it will look like. It does not have like a traditional parachute which we see on Crew Dragon, but a gliding parachute, because yes, that's what they want it to hang in air for quite a long time, so that the helicopter can catch it. So this helicopter slowly arrives to the will arrive. This is what they did for the demo, but eventually this will be done reality also. Now you can see there is a hook in this on this rope, which will eventually attach itself to that you can say the thread kind of hanging of the parachute. You can see, and there you go. They have a very smart system in place, which actually makes sure that the parachute, just after it catches, the parachute closes and it is secured with the helicopter. So they have like a very unique system in place for that. And then obviously the helicopter takes it, the first stage, to wherever it wants, and eventually recovers it. So they have a very different system in place for the reusability regarding the first stage. But let me tell you that this mid-air recovery with via helicopter is not a very new concept. Okay, and Peter Beck, actually, he himself, the CEO of Rocket Lab, himself said that the recovery stage by helicopter is an easier part, but the difficult part is the first stage, surviving the re-entry of the atmosphere without an entry burn. That was the difficult part. So yes, I've actually made a whole video also on this topic, why they are not using parachutes. This sorry, why they are not using propulsive landing to recover the boost. So you can check that out in my channel if you want more about it. Okay. And so yeah, uh, that was pretty much about the rocket. I hope I was able to make you clear. Okay. Now let's move on to the, okay, yeah, I was actually going to make you see the engine scale. This engine is actually 3D printed, not all the parts, but most of the parts are 3D printed in house, and you can see the scale of this engine. It's a very, very small engine, and it is a very clean looking engine. And the reason is the electric pump fed cycle. Yes, this is powered by batteries. These engines are powered by batteries, and that is the reason why, since they are powered by batteries, so the turbo pumps are replaced with motors, kind of, you can say that. And those motor speed can be controlled by the software, so you don't need an actual sophisticated mechanical mechanisms to control the speed of the turbo pumps. Even for the gimbling also, they have this electrical actuator rather than the mechanical one. So everything is very simplified, which is actually what you want for a small set launcher. So that's why this is the actual engine which they are using in the rocket. And you can see it's a very simplified engine, and very small too. Okay, moving on to the next thing, which is the satellite which is going to launch today. So this satellite is comes from Synspective. This is the name of the launcher. Sorry, the satellite and industry satellite company. Sorry, and they have this satellite named as StriX. So this StriX satellite is a small SAR satellite, which means synthetic aperture radar satellite, which is an Earth observing satellite. So this is an 100 kg class SAR satellite that can gather data regardless of weather condition. That is the advantage of SAR basically. So that's why the owl is known for its keen eyesight, and like its animal namesake, the StriX satellite can target data with a ground resolution of 1 to 3 meter, single polarized PV, and a swath width of 10 to 30 kilometers. So resolution of around 1 to 3 meters, and swath is like how much it can image in one photo. So 10 to 30 kilometers is what it can image in just one click. That's in layman terms I'm explaining you, but yeah, that's what it means. Okay. Now, right now, the satellite which is launching will be StriX Beta. StriX Alpha has already been launched by Electron only, and today they will be using launching StriX Beta. This was originally being launched on Soyuz 2, but then it was shifted to this one, Rocket Labs. This is the first generation of the satellites from the company. Then they have this second generation which will have 6 satellites constellation. Then finally the third generation, which in which they will fully deploy the fleet of 30 satellites observing the earth. Okay, so if I talk about this satellite itself, So you can see one very interesting thing is that yeah, they have two observing modes, strip map and sliding spotlight. uh, they have this revisit period of 1 day in Asian big cities by 6 constellation in 2020. Every 24 hours they'll be able to map the same location. That's what they're trying to do with 6 constellation, 6 satellite constellation. Now, as I said, they have this SAR, synthetic aperture radar technology, which is very useful when you don't want weather to interfere with the Earth observation. As I said, it sends microwave from the satellite to Earth and the received and receives the reflected signal to create an image of the target area. The observation by the SAR enables 24-hour monitoring even with cloud coverage when optical Earth observation satellites are less effective. So you can see here, this is how it works. If, no matter how the weather is, even in the cloudy weathers, the microwave can pierce through the clouds. Even if it is raining, again it can pierce through the clouds, and even in night also it can image the satellites, basically the Earth. And the reason is because it is not using light to image it. It is actually using the microwaves which it is sending onto the Earth. It hits the Earth and then it is reflected back to the satellite, and that reflection, or you can say the delay in the reflection, is what calculated by the satellite. It's a very interesting technology if you want to learn about it. That delay in yeah, reflection is calculated by the satellite to generate an image of the Earth. Okay, so they are not using any light sources, rather than throwing the microwaves through the surface and then taking the readings through that. So this is what they will be doing, and today there will be only one satellites. That's it, and that I think this is the lowest with what Rocket Lab has gone. They are just launching one satellite, and that too, weighs only 100 kilograms. And let me tell you, they have like 200 kilograms weight to sun synchronous orbit. So yeah, they are going like 50% cut in the payload capacity with this. Okay, moving on. So this is how the satellite looks like when it is above the Curie stage, Curie first stage, sorry, the Curie kick stage, and this is the StriX satellite. Okay, so this is how it looks like. Okay, now if I, yeah, let's have a look at the inclination and whatnot. What are the characteristic for today's launch? So it is going to 561 kilometer circular orbit. The number of satellite is just one. The launch window is a 14-day launch window, which opens Feb 28 UTC, and it is going to an inclination of 97 degrees, which is a sun synchronous orbit, and just one customer, Synspective, which is a Japanese customer. Yeah. So as I was saying, yeah, but one thing which you can see is that they are using this red patch on the rocket, and whenever you will see this red patch on the rocket, that means they are using recovering the first stage for the rocket, but they are not doing this time, and I'll tell you what else they are doing. Okay, so but for now, just see this thing. As I have discussed, the satellite, the rocket, and yes, the new pad, new opportunities. As I said, the launch pad B will make a debut with this launch. So this is the maiden launch or the first launch from this launch site, and we have seen all the rocket launches from this launch site, which is 1A. This is the 1B, which will be launched, which they will be launching from. And if you are living nearby, you can just go out and watch this in public. This is open for public access. Public viewing area is open basically, so you can go to this Lux Pit Road, if I pronounce that right, to just watch this launch. This is a launch viewing area, LC1 launch viewing area, and the timelines of the launch is simple as it always is. Liftoff happens, then the max Q happens, then the MECO happens, stage separation, then the second stage engine starts, then the fairing separates, then the second orbit is reached, second battery is jettisoned. Before the orbit reach, there is a hot swap which happens, so battery is jettisoned. Then the stage 2 engine is cut off. The stage 2 separation occurs, which separates the upper stage. Then the curie engine starts, and then finally curie engine shut off, and then the payload separates. So curie engine ignition will happen at t plus 49 seconds. So I don't think so we'll see that happening in today's webcast. So yeah, that is. So I think they are we have almost covered everything. Yeah, they are live now, and as I said, this is they are using like this red thing on their rocket. They are not actually recovering it, but they are testing some recovery technology, like improved battery on the second stage, which can actually offset the mass gain which has happened due to the what should I say, the recovery of the first stage, because there is a payload penalty happens, right? Because of the recovery of the first stage, they have to add the parachute. So to increase the performance, they have improved the batteries on the upper stage. So that's what they are testing today. That's why you can see that red pack. Okay, just here.
Good morning and hello from Rocket Lab Mission Control Centre. We are bringing you a live look of our Electron rocket ready for launch from our private spaceport, Rocket Lab Launch Complex 1 in Mahia, New Zealand. My name is Muriel Baker. It's great to have you join us for our 24th Electron launch, a mission for Earth imaging company Synspective that we have named the Owl's Night Continues. We have a tight opportunity to fly this mission today as we work within an instantaneous launch window. That means we will launch Electron today at exactly 09:37 local time or 20:37 UTC. But if we need to stand down for any reason today, we do have backup opportunities available every day for the next 13 days. But back to the pad, and if you're wondering why the view looks a little different for today's launch, that's because Electron is lifting off from our new second launch pad, Pad B, at Launch Complex 1 for the very first time. We operate 2 pads at LC1 now, and between these and our pad at the Mid-Atlantic Regional Spaceport in Virginia, our customers have 3 launch pads to choose from across 2 continents. Having 2 pads in the one complex means we can carry out more than one launch campaign at the same time. And with 3 satellite clean rooms, a rocket hangar big enough for multiple Electrons at once, and other facilities to support multiple missions, we can have one customer getting ready for a mission while another is on the pad ready to fly. So with 2 pads, there is no stand-down period needed after a launch, which makes it possible to launch back-to-back if we need to. There are 120 launch opportunities possible every year from Launch Complex 1, and if you do the math, that means missions just hours apart can take place, not weeks or months or years. Also, if a customer needs a little more time on the ground, as is pretty common, rather than holding up the whole manifest, we can simply bump the next one up the launch queue with 2 pads available. Another bonus of operating our own spaceport is that we avoid paying hefty costs to launch from a range owned and operated by another organisation. Let's check out what more our founder and CEO Peter Beck has to say about our shiny new launch pad.
Yes, please look at this video.
Launch Complex 1 in the beautiful Mahia Peninsula in New Zealand.
this is like one of my favorite launch sites.
And reached ultimate launch flexibility. This means when a customer needs us, we've got a pad ready. From LT1, we've flown over 100 satellites to date, all supporting everything from climate science through to international logistics, maritime surveillance, and soon we look forward to launching
One has become the gateway to space for small satellites.
Well, this is like and they have changed their logo also, guys. This is the first launch of 2022, and everything is looking good so far.
This mission's launch director, Joseph Carpico, will run our operators through their systems checks during one of the gates we need to pass through to get to launch. Let's listen into mission control to hear what they have to say.
Yay! So they have actually improved the what should I say, animation on the team, which is kind of cool. Right now, T-12 minutes, everything is looking good. And talking about the favorite name of this, yeah, this Rocket Lab actually does likes to play with the name of the missions. And my favorite one was that mission, Pix or It Didn't Happen. Unfortunately, that mission was a failure, but literally the name was being showcased by the Electron. Pix or It Didn't Happen. We lost the feed during the second stage engine startup, and then we lost the rocket. So it literally, what should I say, showcased us that what Pix or It Didn't Happen means. So that was my favorite one. And this launch site itself is very beautiful. Mahaya Peninsula in New Zealand. If you like to, if you live nearby, or if you live in New Zealand, please go and visit it. It's such a beautiful launch site. One of my favorite. In fact, this is my favorite launch site in terms of its beauty and where it is located. So yeah, talking about the second launch pad, as he said, they will be launching more frequently now.
Unfortunately, we didn't get the audio through there from mission control, but we can confirm we are going to proceed with the mission and move towards T-0 and liftoff. We are still on track for our instantaneous launch opportunity at 09:37 local time or 20:37 UTC.
Great. Yeah, I was saying the launch cadence or cadence, whatever you want to say, would increase definitely by having two launch pads ready to launch, and you might even see like two rocket launches from two different launch pads at the same time. You never know. It's a small set industry, and it's very, very, very demanding. So as the demand grows, you might see that happening also. And by doubling their launch cadence, whatever you want to say, they will definitely improve the electrons reliability. They will able to serve the customer better, and obviously will bring down the cost and meet the demands of the customer.
Today's mission is launching from. Let's take a closer look at what is on board Electron today. The Owl's Night Continues is a dedicated launch for Synspective, a Japanese company building a synthetic aperture radar, or SAR, constellation. If the name Synspective sounds familiar, that's because Rocket Lab delivered the first satellite in their constellation, the StriX-α satellite, as part of the Owl's Night Begins mission in December 2020. So you can see where today's mission name comes from. Synspective satellites are designed to provide images that show millimetre-level changes to the Earth's surface from space, through clouds and at any time of the day or night. Because it's so accurate and available in all weather, SAR data has a wide range of uses, including urban development planning, construction and infrastructure monitoring, and disaster response. Here's a video from Synspective with an example on how SAR imagery can help in a disaster response to flooding.
And guys, you can see that red patch on the rocket, which is actually indicative of that they are recovering the first stage. But that is not happening today. If you have just joined in, let me tell you that if you are seeing that red patch on the rocket, That does not mean they are recovering today for today's mission. That simply means for today's mission that they are actually trying to test some technologies regarding recovery, like they are trying to test an improved version of batteries on the upper stage, which will actually offset the mass gain on the first stage because of the recovery operation. As you know, they will be having parachute loaded up on the first stage. Because of that, they will suffer some payload penalty, and to can say negate that, whatever you want to say, they are improving with the batteries of the upper stage so that they become more efficient, and hence they don't need to carry like that extra the hot swap is it still happen, but maybe the battery weight is decreased and the efficiency increases. So we'll have to see. That's what they're trying for this mission regarding the recovery status. So yes, right now on your screen is the SAR technology in action. Well, talking about the SAR technology, the biggest and the most advanced Earth observation SAR satellite will be the NISAR, which is being developed with NASA and ISRO collaboration.
That make up a multi-launch contract with Synspective, so you'll be seeing more owls flying later this year and next.
Great. So watching from Canada, flying the bug, that's great. And we have people from Nepal, India, and where not, and Lithuania. Think so. So yeah, people, please just spam in the chat from where are you watching this. Weather is looking great right now, and this rocket itself is very, very beautiful. With that black color of the rocket and that white covering of the ice, it just uh, such makes this rocket such a beautiful one.
As you can see on your screen, we are opening the top clamp on the strong back, getting ready to retract it for today's mission. This is the tall structure on the launch pad you see. It will slowly move away from the rocket to prepare it for launch. The strong back keeps Electron firmly in place, but as we prepare for liftoff, we
Yeah,
move
it is
out of the
moving
way.
away right
So
now. You can
open
see
its
that.
top clamp and retract the strong back about 20 degrees, clearing the way for launch.
Canada,
We are now
USA,
at
Wales,
T-minus 5 minutes
USA.
and
That's
35
great.
seconds, and Electron is looking ready from the pad at Pad B at Launch Complex 1. The eagle-eyed among you will have noticed the red stripe on Electron's second stage. If you've been following our missions for a while, you'll know that normally red is for recovery. However, we are not attempting to recover the first stage from today's mission, but we are continuing to test systems associated with recovery, including enhanced batteries to boost performance of the second stage, to offset any mass gains we carry in the first stage's recovery systems. After 3 successful booster recoveries from the ocean, our recovery program is progressing well, and we are very excited to attempt our first helicopter capture in the coming months. Here's some exciting footage from our latest test.
Yes. Those, whoa, latest, they have actually done one more test. That's great. So as I actually showed you how the test looked like for the initial ones, now this is the another one which they did, which is great. We'll actually see if they have done anything else for this one. Right now I don't think so they're catching it in midair, but just yeah, the parachute is not a gliding one, so they are just testing the parachute opening as well as rocket splashing down in the ocean. And guys, please try to, I can see something, I guess please try to decode that binary or cryptographic code written on the pad.
That whistling sound on descent. Today's mission
parachute,
will
so
be
to say.
our 24th Electron launch, and we have delivered more than 100 satellites to orbit since 2018, none of which would have been possible without our dedicated teams across the United States, Canada, and New Zealand. As we increase Electron's launch cadence and continue development on our larger rocket Neutron and expand our space systems and satellite manufacturing capabilities, our team is growing. So if you'd like to be part of it, check out the open positions on the career section of our website at rocketlabusa.com. But it's time now for the final milestones before liftoff. The team are tracking no issues with the launch vehicle. Synspective's payload remains healthy and the weather is looking clear for an on-time launch. Soon, at T-minus 2 minutes, the switch occurs from our team manually controlling the clock to having the countdown take place during an auto sequence run by the rocket itself. At T-minus 1 minute and 30 seconds, we should hear the call that LOX loading is finished and Electron's tanks are full. And shortly after that, at T-minus 1 minute, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch. Then it's on to the countdown run by the launch director from T-minus 10 seconds and liftoff of the mission for Synspective. Let's go to the audio channels from Mission Control and listen in.
Okay, yes, flying the bug as you mentioned, talking about this rocket, this has like delivered 100 plus satellites to orbit, and this is the 24th launch, out of which only 2 were unsuccessful. So yes, this is a highly reliable rocket and this is not their first launch. So that is the thing, and right now they will be going in for reusability also on this rocket, which is great for a small set launcher because it has to already deal with that payload, lesser payload, and to add reusability in it, it would just mean a bigger payload penalty. So kudos to Rocket Lab to do that, for doing that. Okay, so we are T-minus 1 minute 40 seconds. Everything is looking good. The vehicle is getting ready for the flight. Right now we can see the tanks have been secured. Everything looks great. And guys, just hit the like button on the stream and may subscribe also on this channel for amazing live stream content as well as space related videos if you are into them. So yeah, please do that. T-minus 1 minute 13 seconds remaining. Everything is
disabled.
going as per the plan. And I'm getting very excited right now. Okay. T-minus 60 seconds. This is happening. The first maiden launch from the launch pad 1B. We're about to see that. Rocket Lab is always doing some great things. Fingers crossed.
Deluge is activated.
T-minus 30 seconds remaining.
Stage 1 and Stage 2 are pressed.
Minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9,
9, 8, 7, 6, 5, 4, 3, 2.
Look at that arrow go into the
Stage 1
sky.
propulsion is nominal.
Propulsion is nominal as expected. Don't worry guys, I'll from next time onwards I'll
Plus 40 seconds into the mission and our 24th Electron has lifted off from Pad B at Rocket Lab Launch Complex 1. The beauty of launching in the morning means we had a clear daytime view of Electron powering its way to space for Synspective, but before it gets there, Electron will pass through a critical point in the mission to clear max Q. This is the moment where there is maximum aerodynamic pressure working against the vehicle, hence max Q, causing the most amount of stress the rocket will experience during its climb. Let's listen in for the call.
Max Q has
So we just heard it there. We have cleared that gate. That's what we wanted to hear. Electron's 9 Rutherford engines are firing well and the mission remains on its correct trajectory to space. Now
So
we
it
will run
feels like
through
it's a bit wobbly out there, but it's all right. That's how it is supposed to be.
engines will throttle down before shutting off completely. That is main engine cutoff, or MECO. A couple of seconds later, we'll have separation of the first and second stages, followed quickly by the single Rutherford engine on Electron's second stage, lighting up and continuing the mission to Earth orbit.
Wow, see that beautiful Earth in the background. Right now the plume is expanding. It's
Stage 1
supposed to do
propulsion
that
is nominal, preparing for MECO in roughly 30 seconds.
because the air pressure drops significantly in higher altitude, and that's why the plumes are able to expand. What you see in every rocket.
15
So
seconds to
beautiful
MECO.
view, such a beautiful view. Now coming in for the MECO, 10 seconds or so. Hey, there you go, MECO. Stage separation
Stage separation successful.
and ignition.
Stage 2 ignition.
Whoa, that's always we want to hear. Look
There
at
we go,
that.
we heard it and
red
saw it for
glow.
ourselves. Electron has had a successful MECO, stage separation and ignition of its second stage engine. We're coming up on fairing deploy shortly as well. We'll see Electron's nose cone separate and fall away to clear the way for the Synspective satellite. So let's keep an eye out for that one.
So yeah, Wildflower, that was thrust vectoring. At that high altitude, there is very little
Fairing jettison succeeded.
fairing is jettisoned, and you can see them go. So yeah, that was thrust vectoring.
There you go, you saw the Electron fairing falling away as planned. The rocket's second stage is continuing nominally with its Synspective payload to orbit. The vehicle is currently at an altitude of 130 kilometres and reaching speeds of more than 8,700 kilometres per hour.
So right now the Electron is
HVB battery discharge is nominal.
zooming at 9,000 at altitude 144 kilometers. It has to go to 561 kilometers to.
We are now at T plus
Unsynchronous
3
orbit.
minutes and 52 seconds into the mission, having completed stage separation and fairing deploy from Electron as well. We are coming up next to battery jettison, so that will be coming up in just a few moments. But Electron is looking good, carrying on at an altitude of 160 kilometers and more than 9,800 kilometers per hour.
Always want that velocity to just go increase basically, right? And that's what is happening right now. So the only thing left before the SECO happens, second engine cutoff happens, is the battery jettison or the hot swap, which the Electron does. And this maneuver which it performs.
So it looks like the mission is continuing
is-
nominally as we get ready to deploy Synspective's satellite to low Earth orbit. We are at T plus 4 minutes and 43 seconds into the mission. It's traveling at speeds of more than 11,000 kilometers per hour and at an altitude of 185 kilometers.
Yeah, I was saying that those, as I said, this is electric
Stage 2
battery powered
propulsion is
engine.
nominal.
So this consumes battery to rotate those turbo pumps, and when those batteries are dead or fully consumed, those need to be swapped with the new one. So it carries like 4 batteries with it. 2 are used in the initial part, and then those are swapped with the second pair of batteries. So the first pair then needs to be jettisoned to reduce the weight, and that's what is the hot swap or the battery jettison, which you will see
When they run down their power and move to a new one to keep things moving. The process of switching out this power source mid-flight is what we call battery hot swap. Sometimes you can catch a glimpse of these battery packs falling away. Let's watch and listen.
this silver thing out of the view now.
Throttling down.
Approaching hot swap.
And a
Battery jettison
wow,
confirmed.
that was great.
Hot swap.
And there they go. Thank you, battery packs, for your service. Electron's trajectory continues to look nominal as we hit T plus 6 minutes and 25 seconds into this mission.
Okay, 15,000 kilometers an hour. They're looking great. Battery hot swap has happened. So that is like the
AST is saved.
last critical moment before SECO happens. So now the mission probability for success is very high. It will burn for
HVP battery discharge holding nominal.
things are looking now. We have lost the video feed, but you can see the telemetry. It is regained that. They're looking great. Everything is well.
If you're just joining us for this mission, our 24th Electron launch, we are well on our way to low Earth orbit for Synspective satellite on board Electron today. So we are at T plus 7 minutes and 24 seconds with Electron carrying on nominally. We've made it successfully through our mission milestones to date, and coming up next will be the engine cutoff on stage 2. So that's coming up in just a few moments.
Up, and you can see the altitude is actually decreasing rather than increasing, and that simply means that the apogee has been attained, and now it is not the apogee. Yeah, apogee has been attained, and now it is going towards the perigee, or since the engine is running right now, so the apogee changes also. You will see that happening. Obviously the final orbit is at 561 kilometers, so 200 kilometers is not.
We are about a minute away now from the second engine cutoff on stage 2 of Electron, but the mission is carrying on nominally at T plus 8 minutes and 20 seconds, and we'll be coming up to that milestone shortly.
Okay, they're looking great for now, and SECO is coming up very shortly now. Don't worry about the altitude decrease, guys. That is completely nominal.
Electron is now coming up to its next mission milestone, SECO, or second engine cutoff. Like when we shut down the main engines earlier in the mission, the second stage single Rutherford engine will stop before the stage separates from the kick stage and the mission continues to orbit. So we've had MECO and we are coming up to SECO. We do love an acronym in the space industry.
AWST. So then we have this UPEX also.
SECO confirmed.
What not? So many.
SECO is in transfer orbit.
Okay, SECO confirmed. Everything is looking great. We'll have to wait and see whether they will show us this curie ignition.
So you saw it on your screen there. The Rutherford engine on Electron stage 2 has successfully throttled down, and stage 2 and the kick stage have cleanly separated. The kick stage will now enter what we call a coast phase. For the next 50 minutes or so, it will do its first lap around Earth in an elliptical pattern. When it reaches the apogee of this orbit, or the moment it is at its highest point on this egg-shaped path, the Curie engine will fire up and put us in a circular orbit. Once there, we'll deploy Synspective's StriX-β satellite. We won't have a live video feed of payload deployment, unfortunately, but do stay with us because we have a simulated view of that happening that we'll come back to as the mission closes in those final moments. We'll take a bit of a break now as payload deployment is expected to take place at T plus 53 minutes, so I'll see you back here then.
Okay, that is great. Although the thing is, this Curie kick stage, as I said, we don't know much about this kick stage, and you can see also that we don't get much of the views of those kick stage, right? And here also you are not getting any views of from the onboard cameras, if there is any, from the kick stage, because that is like the secret thing which Rocket Lab has, so they don't want to reveal it. So yeah, so we have like a good amount of time for anything happens, so we'll have to wait and see, but everything is looking great. And right now you can Whoa, see those circles? Those are, I think, the ground stations. We can actually see the satellite also here. So, yeah, the rocket or the satellite. Actually, the third stage has been separated. Stage has been separated. So, right now things are looking as per going as per the plan, and this know, launch is at the sun synchronous orbit, and that's why you can see it is going towards the south pole right now. Then it will emerge from the south pole to the African side. Yeah. Okay. So what I was saying, yes, now they have tested the battery enhanced batteries on this mission, and I don't think so they faced any issue here. So that was a successful mission, and yes, they launched it from the launch complex 1B, which was the maiden launch from the second launch pad, and the liftoff views were phenomenal, uh, as they always are. And yeah, now we will wait for the payload separation to happen. Guys, if you are just new to this channel, let me just tell you that on this channel do these live streams, informative live stream, not just the live stream, informative live streams with everything A to Z that you need to know about a rocket launch, or even a normal space you know thing, space related thing which is happening, which is kind of interesting, like landing the moon or something like that. So I do the coverage of those things, as well as I have other space and rocket science related videos. You can go check that out. And guys, it would mean a lot if you can support me in my endeavor, and by becoming a member or a Patreon. Links are down in the description. It would mean a lot. So Fly in the Bug says, you seem to know your stuff. Thank you so much. Although I'm still learning, but yes, I do know some stuff. Do you know why Electron starts coast phase at like 1000 km/h faster than Falcon? See, this faster, or the velocity, is all dependent on where are you going. Okay. Right now, as I said, this is going to 561 kilometers of the altitude. The apogee is around 561 kilometers, so they have to add like some more velocity than the Falcon 9, because the Falcon 9 launches, if you are saying about the Starlink one, they are not so high. That 500-kilometer is like the operational orbit for the Starlink satellites, but the deployment happens at around 200 kilometers or so, and then the onboard propulsion of the Starlink satellites take place. So they are going to a higher orbit, so they need to add like more energy to the vehicle or the satellite, and that's why they need to add more delta v. That's the term here, basically, the delta v, the change in velocity. And to go to the higher orbit, you need more speed. So yeah, that's why the coast phase started like 1000 kilometer more than the SpaceX Falcon 9, because they were going to a higher orbit. And this coast phase will be even higher if they are going for a geostationary orbit, which you will see tomorrow, because tomorrow we have the Atlas 5 going to space with the GOES-T weather satellite, which would be very amazing to see. So do join me for that also, and there you will see uh, you know very high velocity when the coast phase will start, because it will be going to geostationary orbit, which like has which has like 36,000 kilometers of apogee. So yeah. Okay. And talking about the commands, Angel, which you were typing, actually I haven't activated the commands on this channel right now, so that's why they're not working. But occasionally you can see those links are being spammed on the chat. for the Discord as well as for the members. Okay. Yes, Wildflower, you are right about the ping pong and this truck analogy, but that does not work in space actually, because there is, um, if you are in one orbit, okay, let's say 100-kilometer circular orbit, okay, then no matter what is the weight of your satellite, if you have like can say the monstrous a Saturn V or a starship, a fully assembled starship in orbit at 100-kilometer, and let's say a pen revolving around the Earth at 100-kilometer orbit, both will have the same speed, same velocity. Okay, so yeah, that's how the orbital mechanics work in space. The orbital mechanics are very, very tricky sometimes, because whatever we think, it does not work like that in space. Like if you have even ever thought of like if you are on ISS in a space station and you are trying to throw a ball to the Earth, what you will do? Would you just throw it directly towards the Earth, or would you throw it in the reverse direction of where the ISS is going, which is more efficient? Your brain would suggest that if you want to go towards the Earth, you will want the ball to go towards the Earth, you would just throw the ball towards the Earth, right, in the 90-degree angle to the space station. But that is not how orbital mechanics work. To for that ball to go to the Earth, you need to throw it in the reverse direction of where ISS is going at a very high speed, and that's how it will be able to go towards the Earth in a more efficient way. Because vector addition of velocities, if I am making some sense here, will cause that error. Okay, one is when you are throwing just towards the Earth, the vector addition will cause the velocity to not decrease at all, almost not decrease at all. So yeah, the main thing is, the motive for my this conversation was that orbital mechanics are a bit tricky to get uh, sometimes. So yeah. Yes, flying the bug. That is what I was trying to say. Actually, in space, mass does not play a role. Actually, whenever we want to deal in any maneuvers or so, we deal in delta V, right? Because delta V is what we are looking forward to whenever we want to perform a maneuver. Change in velocity. That's it. We want some change in velocity to attain a certain orbit. We don't care about the mass. Obviously, yes, you are right. If we have like a huge mass, then to attain the same level of delta V, more fuel would be required. Okay, rather than for a small pen or something like that. So yes, mass plays a role in the fuel requirement, but the delta V remains the same for to attain a certain orbit. When you reach a certain delta V, then all are equal weight wise. Correct? I don't understand your question, but if you want to say that like at 100-kilometer orbit, all are moving at same velocity, yes. But I actually didn't understand your question. Yeah. Once you reach delta V, then all are equal weight wise. Yeah, I think you are meant to say that only. At 100-kilometer orbit, whether it's a pen or a starship, all will be moving at the same velocity. And yes, regarding this orbital mechanics thing also, talking about drag in the orbit, you must have like you know seen this or heard of drag in the orbits, and but there is no atmosphere in the orbit, in the space. So how come we have a drag in orbit? uh, I would say we have an atmosphere, but it is like very very thin. In fact, we have scientists have recently discovered that Earth's atmosphere is expands till the moon. At the moon also we have found some atmospherical atoms reaching in the orbit of the moon. So you just don't know. It's like very very thin atmosphere. We have like atoms going, the ozone layer atoms, the nitrogen atoms, the oxygen atoms going those orbits. So because of that, drag happens. And drag, as I was saying, drag actually does not depend on the mass. Drag depends on the surface area. If I go into more mathematics of it, F is equal to a rho vt. I think that was the equation. I don't remember. But in that equation, if you are mathematical or equation guy, you can see there's no mass. So drag does not depend on the mass. It just depends on the surface area. So uh, whatever, if you have like okay, yeah, I in it right now, advanced topic. So but yeah, I was saying that only the drag actually does depend on the area, but not on the mass. Hundred molecules per centimeter square is the month's atmosphere. Yes, months. Mom's atmosphere. Okay. Your mom has an atmosphere. I didn't know that. Cool. Mun. Okay. We have mun in here. You see, this is the bad thing which we have gained by playing KSP, right? We call our moon also as mun, right? I don't think so. You decide whether it's a bad or a good thing, but I also myself sometimes say moon as mun because of the KSP hangover or whatever you want to say. But yeah. So right now you can see the simulation. It is just emerging out of the poles and going and will be going over the Africa. Yes. Guys, hit that subscribe button for more such information on the streams and all those, and do consider becoming a member. Would certainly help me in bringing these live streams. And I am actually planning to improve my live stream coverage with uh, animations and whatnot. Let's see if I'll be able to do that. But yeah, you would see some stream improvement in coming days. That's for sure. See, actually, the drag would depend on the area vector. If going into um, area has a vector, and if you are okay, let me explain simpler words. If you are going at a prograde, which is like in the direction of your speed, if that part is like more aerodynamic, then then you would experience less drag. But if you are going into towards the velocity with a part which is not very aerodynamic, then that would experience more drag. So to answer your question, with the oval which is facing which is facing drag at a 90-degree angle, yes, it would experience more drag rather than if it is at the pointy end. Okay, so yeah, that is the thing. Yes, Nishant, that is what we have in the uh, equation. I can't remember the actual in equation for the drag right now, but I do remember there was no mass in it. So I can say for sure it does not depend on the mass. But again, see, this is one thing which you should know, that drag does not depend on the mass, but the momentum does depend on the mass. And since the momentum is directly related with inertia, more the momentum, more the inertia, so therefore to stop a heavier object, it would take more time, okay, than a lighter object. So if I have like 100 kilogram object in space which has the same area uh, uh, with that of a 1 kilogram object, the 1 kilogram object they both will experience same drag, but 1 kilogram object more will become slower more quickly because of that momentum factor. It's very simple to understand these things. Like you just to understand the Newton laws, na, just need to understand it. Okay, what is inertia? If some body has a higher inertia, it would be difficult to stop. As simple as that. So if it is difficult to stop, so it will take like more time to stop it. Imagine it like this: there is one object going in one direction, and then the drag is applying the force in the other direction. But that drag is a constant force which is being applied on that object on the other direction, which is actually the constant. But since the inertia of a heavier object is more, so that drag will take more time for it to slow down. I hope I made myself clear. See, these things which I am saying, na, those things can be more easily understood, visualized if I have like a certain whiteboard or paint in front of me, so that I can make things and make you understand those things. The problem with me talking is that I have certain pictures going in my head, and according to that I'm saying. I don't know how well you are able to visualize it. So it is always good to have certain animations or visualization with a pen or paper, so that I can make you all visualize what I'm trying to say. So yeah. See, outside, see, in the bug, there is one thing which you need to understand. Yes, there is atmosphere like till the moon, but the effect of the atmosphere, which is actually seen greatly, is in Leo only. Even in Mio, which is like 1,000 kilometers or so, I don't remember the range, but medium Earth orbit, it is significantly less. So, and in geostationary orbit, again, it is significantly less. Very less. It is negligible in there. So, Apollo missions had this. I don't remember if they had this drag issue or what, but what I know is in Leo, you can experience the effect more significantly, and it reduces as you go up higher. But the problem when you go up higher is that you are not very much bound with the Earth's gravitational field, right? When you are like in a geostationary orbit, 36,000 kilometer, there the problem is not drag. There the problem is perturbations, right? Since you are away from a gravitational body, you are more likely to get influenced by other gravitational bodies. So in geostationary orbit, we also have this thing called station keeping, because uh, in geostationary orbit, perturbations happen, which means they get influenced by other gravitational forces in bodies like Moon, the Sun, Jupiter, or so. So because of that, the orbit of a geostationary object changes, and that's why in geostationary orbit also you need station keeping. Okay. And in a low Earth orbit, you need station keeping because of the drag, but in geostationary orbit, you need station keeping because of the perturbations. In Leo, the perturbations are negligible because it is very close to a certain body, is the Earth. So the Earth is the only major gravitational body which is coming into play, and hence you can ignore other gravitational bodies. See, JWST is need to keep fire to adjust it. Yes, that is the thing. Is that is what I'm talking about perturbations. Okay, when you get away from a body, you tend to experience more and more effect of the other gravitational bodies. Okay, so regarding JWST, it has to do course correction with time to time, because not because of the drag. Okay, because of the perturbations, which means it is experiencing forces not only just from the Earth, but from the Moon, from other planets, from Jupiter, even from the Sun. And because of that, its orbit changes, and then we need to fire its engine again to correct the course. This is the thing which happens with every interplanetary mission, even the Mars mission also, and even the lunar missions. To go to the lunar mission, you need to do course correction just because of this perturbations. This is a very good what should I say, concept. When you are in a low Earth orbit, then it is just one body perturbation. When you are in the geostationary orbit, then you can say kind of two body perturbation, two or three body perturbation, in which you get to play with the Earth, Moon, and Sun gravitational fields. Then when you go into interplanetary space, then it becomes n body perturbations. You get to play with every other body, even asteroids also. It would depend on like how close you are with that body. So yeah, the course correction needs to be done because of those perturbations. Nihilist human, you got a very good question out there, and yes, it happens. It happens. The light actually can change your course, but photons, as you photons does not have a mass. This Einstein has the experiment has already suggested it, that photons does not have a mass, but it has a momentum. Since it has a momentum, it can impart that momentum which it is carrying to another body, and that's why there is a certain concept of solar sail. Okay, there has been a concept of solar sail which was studied also, and maybe you will see that in action, in which you were to deploy a very big sail in the interplanetary space, and then you just need to make sure that it is always pointing towards the sun, and the compounding effects of the photon hitting that solar sail would just slowly and steadily increase the velocity of that object, and it would go just out of the solar system. That system is being studied. Okay, and there is also one more system to send one, like a very 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 small satellite, like 1 centimeter square satellite, to light years away using a very very powerful laser being focused on that satellite, using this concept only, light imparting momentum. So this is a very good question, and yes, light does impart momentum and can change the course. But with the like other satellites going to Mars or so, which are very 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 heavy, light does not play a role. But if you want to play with those light kind of things, you need to develop a solar sail which is very very light, and yeah, then you can see the effect. See, space is always a fun stuff. Okay, and that's why I'm into it, and that's why I want everyone to explore this field, because this is such a beautiful, and the discoveries are endless, and the concepts, even the concepts to understand certain things are very 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 innovative and very uh, beautiful, that space will always excite you once you get into it. And that's why whenever if a person is very afraid of the word rocket science or space, I always say him or her that you don't need to worry about any rocket science or something like that. Just enjoy the view, just enjoy the imagery when the rocket lifts off. Just enjoy those images which comes out of the satellites. Once you are into that, then you will slowly and steadily um, get interested with how the things would work. And once you get interested, then rocket science and space is like the only field which, when you dive in, it will take care of you, and will take a good care of you. That's what I can say. So yeah, talking about slowing down the thing, no, we can't actually slow it down, because um, the what should I say, the momentum is just being put on to the solar sail from just one direction. You just can't slow that down, because you can't. It's not like engines which you can just point into the retrograde direction and start the engines again. It's like, if you want to slow it down, you would have to uh, take the sun from one position to the other one, and then the photons will start imparting the momentum onto it, and then it will start slowing down. So no, this kind of system, solar sail, is made to explore the universe. Okay, that's why it was being studied. It was not being studied to circularize in some planet orbit or something like that. No, just object going into space, into intergalactic universe, and just going beyond and beyond and beyond, and that's it, without any engine. Just the compounding effect of the light being imparted on it. That's it. We really did not know. Yes, so that poem is actually valid now also. We don't know stars. We have studied them, but again, mysteries are endless. See, ocean and space are very closely related to each other. We haven't even explored our oceans yet. We have only explored like 5% of our oceans. Going into ocean and exploring it is very similar to going into space and exploring it. There in space you need to deal with zero pressure. In ocean you need to deal with like very high pressures. But the concept remains the same, that you need to airtight your vessel so that nothing goes in and out. Yeah, ocean and space is very closely related to each other. So that's why you will actually see space agencies working on submarines or any scientific missions related to oceans, because space and oceans are very closely related to each other. Well, I would say that yes, you are right in that prospect. Oceans is kind of a bit more harder to explore because of that huge amount of pressure in there. But yeah, again, space, you have the problem with the distance and no help coming from above. In ocean, see, that is not the issue. You can get the help very quickly, but again, that pressure is constantly killing you. It's like, you are trying to dive into the Jupiter's atmosphere. You can make something which can handle the ocean pressure in the ocean bed. Then you can certainly make something stable for Jupiter's atmosphere, or even the Venus mission, Venus lander. That would make so much more sense, and that's why I say space and oceans are kind of connected to each other. There's been like some hypothesis also that Jupiter's atmosphere is so thick that you actually may find some metallic hydrogen in there. And metallic hydrogen has not been found anywhere and has not been made in the lab, but the properties and the probability of it being generated has been found. Like, the calculations have been done, so it may exist in nature, but we just don't know. But the right conditions for metallic hydrogen formation is in the Jupiter's atmosphere, because of that tremendous temperature and pressure it gets. So because of that, metallic hydrogen gets produced. That metallic hydrogen has like, you know I can't even what should I say, has such a good amount of properties with it that you can do so much with metallic hydrogen that I can't even list that down right now. And same thing goes for that wormhole. Wormholes are very theoretical concept, but you never know. Maybe wormholes exist in space. We haven't just found one. And for the stable wormholes to exist, you need the negative mass, exotic matter, and whatnot. And then this negative mass is also very intriguing. If you go into this to study this negative mass thing, with the negative mass, you can not only create wormholes, but also can create FTL drives, which is like the faster than light drives with negative mass. It's just a theoretical concept. Don't know for we haven't discovered any negative mass right now. Negative mass is simple. Like normal masses attract each other, negative mass will repel each other. As simple as that. Submarines usually not get rescued. Yes, I mean you can say that, but it's reachable. I would say that at least. But with space, if something happens, you are in deep space, and if something happens, you can't do anything. You just can't do anything. But with submarine, at least you can go there in some few hours or something like that. But no, nothing can be done in space. Ocean needs to be explored because see, simple logic. The starting of our life began from the water, right? And we haven't explored the water yet. As simple as that. And we don't even know what we are missing. Just don't know what we can find on the ocean beds. Maybe some very creepy creatures, maybe like SpongeBob living there, chilling out with Patrick and whatnot. Squidward. Yeah, we need to explore oceans more. The water is like the building blocks of life, and we don't know what we can find. Maybe some creatures or some atoms, some molecules, something like that, right? And now I think Curie ignition burn has started. We'll have to wait for the official confirmation, but I think it has started now. So it is trying to raise the apogee, or maybe it is right now on the apogee and it is raising the perigee. So the curie burn has been completed as per the time now, and we are getting ready for the payload deployment in just 2 minutes or so. So everything is looking good for now.
Welcome back to the webcast of Rocket Lab's 24th Electron mission. The Owl's Night continues. If you are just joining us, today's launch included a successful on-time liftoff at 09:37 New Zealand local time, or 20:37 UTC. The kick stage has completed its first pass in an elliptical orbit of Earth, and we've had a successful Curie ignition to position the kick stage in a circular orbit, so we can deploy the Synspective satellite on board.
There you go, guys. You will see the animation, but not the. You can see the Curie engine. It's very, very, very small there. It's like a thruster. I would rather classify it as a thruster than an engine. And there you go, the separation. I think it has been confirmed now.
So good news, while unfortunately we didn't hear it on the audio channels, I can give you confirmation that the Synspective satellite has been successfully deployed by Electron on this, the Owl's Night Continues mission. That completes today's 24th Electron mission and officially brings the count of satellites deployed by Rocket Lab to 110. Congratulations and thank you to our customer Synspective on this latest successful launch. We're already looking forward to our next mission with you later this year. A reminder that we are always on the lookout for new talent to join the wider Rocket Lab family, so if you're interested in joining the team, check out the careers page of our website at rocketlabusa.com. And a huge thank you to you at home for tuning into the live stream of this mission. We're going to end the broadcast here, but remember to follow our Facebook, Twitter and Instagram pages for information on our next launch. For the first time from Pad B at Launch Complex 1, this is Rocket Lab Mission Control, signing off.
Well. That was a great launch. We had a beautiful views of the liftoff, and this is right now the live views of the pad. We can see the people out there, but yeah, was a beautiful liftoff. Everything went as per the plan, and finally, the StriX satellite is in the intended orbit. They have done an incredible job, as they always do, and made the customer satisfied again. So now that's it. I think. Thank you so much for joining in. I really appreciate it. But yeah, I would rather. So yeah, Curie burn payload separation completed. So we have certain updates also coming in. Basic Starlink is working Kiev. That's great. It's official. Neutron is coming to Virginia, bringing the future of the launch. Oh, and Neutron is just something built different. You can see it here, and it's coming to Virginia for construction and production launch site. That's great. If you have, then go on and apply for the job. The rocket looks amazing, I must say that. Okay, the okay, I think that's it. We don't have any other important update for now. Although I must say that the OneWeb is launching, at least for this time. OneWeb is launching on 4 days from now, and would be very awkward to see now that I don't know what would happen with the PR with the one web or what, but let's see how the things would look like. I'm looking forward to that launch. That might be the you never know. That might be one of those very last Soyuz launches also. Just never know. Okay. I think that's it for today, guys. Thank you so much for tuning in. And please, and congratulations to 12K subscriber. Oh, I completed it? Yes, I have. Oh, thank you so much, guys, for all your love and support. Really appreciate it, man. But it takes a lot of time to for me to like plus 1K subscribers. Almost like what should I say? Months, 3 to 4 months just for 1,000 subscribers. Okay, I think okay. So thank you all for tuning in, guys. Appreciate it, man. And you, if you want to support me, you can do that. Again, repeating, please support me. It would really mean a lot. Uh, Actually, where I am planning to do some sort of investment on my. I really need some money, so it would be great if you could, support me in that by becoming a member or a Patreon. And tomorrow we have another launch coming in from Atlas 5, as I said, the Dominator 541 configuration. So tomorrow we'll meet at this time only. It's like 3. It's yeah. This time only. Tomorrow we have a liftoff scheduled for the Atlas 5 mission. So we'll meet at around T minus 60 minutes or so. You will see the notification. Don't worry about it. So yeah. Okay then. Until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and